So we want to look at another application of animation. So I want to drop a ball. We did dropping ball already, but now I want to modify that or extend on it to do a bouncing ball. So I want the ball from dropping ball to go down, and then each time it hits the ground, I want it to bounce up to a height 50 pixels less than its last starting position, and then go back down and bounce back up and back down and up and down and up. So until it can no longer bounce back up again. So just to remind us that dropping ball code had a 400 by 600 window, and we had a 50 by 50 red ball that ran through a loop from 0 to 55 to get down. So because the top corner was at a height of 0, and the bottom corner was at a height of 550. And the change in Y was 10 each time. So go back to bouncing ball. I'm going to go ahead and pop over to Eclipse, and I have drawing ball open. I'm going to make a new class called bouncing ball. And I did something weird here, so I think I hit something wrong. Java class. I did an interface, not a class. And for some reason, it's not seeing my source code folder. So 3G source code bouncing ball. And then what I want to do is I want to just remind us what dropping ball looked like. So I'll run that. I modified it to have that black rectangle at the bottom. We don't need that. All we really want is that first loop that brings the ball down. So that is in main. I'll just copy main out of here. So main ends here. I'll copy main. I probably don't need the closing parentheses. So everything inside of main is from here up to there. And then I'll paste that into main in bouncing ball. And then I'll have one error that's this draw scene. So I could just delete this line, or yeah, let's just delete it. I could comment it out. I think I'll just delete it out. Okay, so here's our loop from 0 to 55. We clear the screen, and then we make the color red. We're not changing the color anymore, so we might just take that code of set color and put it up here, so I don't have to repeat that in the loop each time. And then it fills an oval and it sleeps, and then it clears it and does it again. So let's just watch it again. Okay. So now that ball goes down. Now I want it to go back up. So I'm going to first put my comments in here about what we're doing. Let's go on top of these imports. So notice it imported automatically for me. Eclipse did that. It imported the graphics, and it imported the color. This class will extend dropping ball and have the ball drop and then bounce up to a height 50 pixels less each time until it stops. I'll say until it stops, but that means that the 50 pixels less would be at the same place where the ball is, so it'll just stop at the bottom. Okay. So put those comments in, and I'm going to jump back over to our paper and try to figure out how we're going to do this. So what we have is we have a window that is 600 by 400, 400 by 600. That's probably a little thinner than the actual window, but whatever. And here's where we're starting, the red ball, and it's dropping down to the bottom each time. And there it is. So in the initial thing, it has a slope, the change in y, or let's call it m, is a positive 10 each time it goes through the loop. So that's in our code, that's this 10 times I here. And it starts off, let's see, how do we figure that out? It starts off at a height of 0. So let's call that the y-intercept b equals 0. And this guy goes down. And it goes down as I runs from 0 down to 55. And the y values go from 0 to 550. Okay. So that's the first drop. And then in the next drop, well, it has to go back up now. So now the slope m is a negative 10, and it has to go up to here, or it's 5 less times. So I would again start at 0, but now it would only go to 50. But the y value would start at 550 and go back up to 50. Once it gets there, so that needs to run from 0 to 50. Once it gets there, we then need to go back down from that same height. So now m goes back to positive 10. I goes from 0 to 50 again. But now y goes from 50 down to 550. Okay, and I'm going to scroll down a little further. Let's see if I can make this bigger. And then when it goes back up the next time, again, we have m has to be a negative 10. And the I values are now still starting at 0, but y is still 550. Whenever it goes back up, the y value, the starting y value will be 550. But now I will only go to 45, and the end value will be 100, because it's going to be right here. Each one of these boxes is 50 down. So 0, 50, 100. And then it has to drop back down. So then m is a positive 10. I goes again from 0 to 45. So it has to do this twice each time. And it starts at the y value. Sorry, this isn't b, this is y. The y value here is 100, and it goes down again to 550. Okay, so there's a loop involved. So I think the first thing I want to do is I want to take the code that we have, and I want to think about what's changing each time. So each time there's this initial run through here, and what's changing is the slope and let's call this the upper value on I. Let's call that n. So slope is m. Let's call this n. And then what else is changing? So both the start values for y is changing sort of in each pair. So in the first pair, b is 0. And that's not a pair, sorry, that's just a single one. And then in this one, the initial value for y is 550. Actually, always, because that's the bottom. And then we don't care what this ending value here is so much as that then becomes the starting value of the next one. So how many times do we have to do these loops? So let's call that, so it happens once initially, and then this will be a loop that calls this function twice. I want to figure out how many times that has to happen. So it's going to keep going until, let's see, the last one is when the ball just goes to here. If that makes sense, it'll go up and then back down and we'll be done. So that is when, let's see, m is going to be -10 to get up to that. The starting value for I will be 550 still, when I is 0. And then I will only go to 5, and it'll go up to 500 here. And then m will have to come back down. Again, the start value when I is 0 will be the 500. And then when I is 5, it'll be 550 again. And then it'll stop. So the loop is running, so n is going from 50. I'm going to ignore this one over here because that's only running by itself. The pair are running when n starts at 50, and then n ends at 5, and it decreases by 5 each time. So that could get us the n values. I'm trying to think is n somehow related to this start value here? So if n is 50, I got to figure out this start value. To do what? Sorry. When how high does it go back up? So this first one is going back up to 50. I got to figure out what the B's do. These guys, the y-intercepts on the up. The y-intercepts on the down are always 550. Sorry. When the ball's going back up, the y-intercept's always 550. But how high it goes is this other y-intercept, let's call it B, and we don't know yet what that is. That looks like it's dependent on, well, so that's what n's doing. Maybe I shouldn't use n, maybe I should use another letter j and just figure out how many times this loop is going to run. I think it's going to run, it's going by 5s here, so that would be 10 times. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 10 times. So let's call a j from 1 to 10. And when j is 1, n is going to be 50. When j is 2, n will be 45. N will decrease by 5. And when j is 10, n will be 5. And this will allow me to figure out those y-intercepts. How high is it going? When j is 1, it's up here, the y-intercept is 50 for when the ball is going to fall back down. And these are going to increase by 50. So when it's 2, it's going to be 100, 3, 150. And when it's down here at 10, 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. Which makes sense because the last one, that corner is at 500, a height of 500, and it's going to come back down to 550 and stop. Okay, so our loop's going to run from 1 to 10 times. We know n, we know b, and I think that's all we're going to need. So it's a little confusing. I realize that, but let's jump over to our code. And the first thing I want to do is I want to put this loop into this code, this loop into a method. So let's call that method move ball. And the parameters on that are going to be an integer n, that's which number, the height we're on, another integer b, so that's going to be this 10, this, I'm sorry, n is not the slope, n is how high we're going, how many times we're going, how many times we're running the loop, sorry, the inside loop. So n is going to be how many times that loop is running. So right now it's 55. That's going to be the n right there. So integer n, integer b, and we need integer m for the slope. And that m is going to be either 10 or negative 10. Sorry, and I'm not defining this correctly at all. But those are the variables that are going to be the parameters. We need to go public static void move ball, and then we also are going to need the graphics objects. Let's call it G, and the drawing panel. Because those are the graphics objects so we can draw stuff, the panel so that we can make it sleep. Doesn't like something, probably has some inside of main here. So I need to get out of main, copy that out of there, get below main, paste it in. Okay. And the first thing I want to do is move this loop inside there. Okay, then in this loop, the upper value will be n. The slope here is m. The b is the y value where we're starting. So that's going to be, let's see, fill oval. That's the height, that's the x value. It's going to be plus b here. mi plus b. So initially, the first one, b is 0, and m is 10. That's going to move it down. And then 50, 50 is the dimensions on the ball. So if I make a call to this function now, move ball, I'm going to send in 55, a slope of positive 10, and a y-intercept of 0, along with my graphics object and my panel. And this function call should move the ball down. So that recreates dropping ball, excuse me, using the method move ball. Hopefully. Perfect. Now, generally I might put the G and the P first, just because those are sort of, I don't know, they're bigger things that have more to do with the graphics, and then the M, N, and B have to do with the specifics of what the function is, but that's fine. Okay, so now within main, we're going to run a loop, and that loop is going to be based on the J value here. So J is going to go from 1 to 10 for integer J equals 1, J less than or equal to 10. Notice the spacing here. It's good spacing. J is going to increase by 1. I think probably the easiest thing is to introduce M, N, and B, integers M. I don't need M. I just need N and B. outside of the loop. I could do it inside the loop, but I don't want to reintroduce them each time. So I'm going to introduce them out there, and then I'll assign them in here. Maybe I don't even need N and B here. I can just use it within the function call. So the first thing we need to do is have the ball drop back up, bounce up. So to bounce up, we're going to call move ball. Okay, so now N is how many times this loop needs to run, and initially N is 50. So that as a function of J, it's, let's see, we got to write this as a function of J. So the slope here, that's going down 5 every time this goes up 1. So the slope is -5. So N is equal to -5J plus, not 50. We got to go back up 1 to the 0 spot. So it'd be plus 55. Which makes sense because 55 was what N was initially. And the -5 is the slope. So in this thing, the N that I'm sending is -5 times J plus 55. The B value will do the same thing. Think about what it is when J is 0. B would, this B is for when you come back down. So right now we're going up, and that B value is always the same. Messy, but it's always 550. Actually wants the slope next. Slope going up is -10. The B value going up is always 550, and then we're sending the graphics object and the graphics panel, the drawing panel. So that should move the ball back up. And then we want to move that ball back down. The N is the same. Yep, the same, negative, because it runs the same amount of times in each loop. This is running 50, that is running 50. So N is the same, -5 times J plus 55. Think about this when J is 10. That's -50 plus 55. That means you're going to run 5 times to the last one, which is right. Up 50, down 50. Now the slope is +10. And this is where we need the B value. The B value is here. So B equals something times J plus something else. So the slope here, these have increased by 50. Each time those increase by 1. So it's 50 times J plus whatever the value is when J were 0, which would be 0. So plus 0. So we don't need that. So it's just 50J. We can check that. When J is 1, it's 50. When J is 2, it's 100. Makes sense. So that's 50 times J. And then we're also sending in the graphics panel G, the graphics object G, and the graphing panel P. And my guess is this is all going to happen too slow. So we're going to speed it up by making the sleep 50. You know, is it going to work? I hope so. It did a lot of stuff in there. So, you know, it's easy to make mistakes in what we just did, especially I went kind of fast. There it goes down. There it goes back up. It should stop. Boom. And then it comes back down. Nice. Goes back up. And, you know, so this is going to run 10 times. So it's working. To see that it actually works completely, we would get to the end. Again, it has this flashing. I mean, I could have it move less than 10. I could try to get it to move a little faster. kind of cool. There it goes, done. There's a little bit of repetition. I don't know if you can see it. But these, well, I was going to say in these 2 lines of code is repetition, but not really because of these start values changing. And so it would be very hard to like try to figure out how to, if it were just the slope that was alternating, negative, positive, we could use like a power of -1, like there's negative, positive, negative, positive. So we could sort of do a loop that just loops the positive and negative. But also because this guy over here is changing, I don't think that makes sense to do that. So we might add some commenting in here. We might say, bounce the ball up. Well, up always starts at height 550. And then this next one, we could say, ball drops back down from a height of 50 times j. So that kind of explains the y-intercept here and here. We could also explain the slope. This one's going up. So we could say, slope -10. This one's going down, slope of +10. And then maybe even up here, we could add in a comment that sort of says, initial drop of the ball from the top. So that comes down and it goes back up, down, up, down. So the up and down go in pairs. And that kind of explains a little better what happened. Okay, I think that's it. Bouncing ball. Again, you could have a background in there somewhere, and you would just call that method draw background within, I guess within maybe move ball, or maybe even within main. I think move ball would do it. So in move ball, if you had a method draw background, then it would always draw that background after the clear, and you'd always have that background in there. So this is another way to sort of have some movement and use loops. And notice this is tough. The way I did that without any redundancy and errors, or that is not easy to do what we just did. And I want to kind of be clear on how I did it, or where I did it, more importantly, back over here on paper. And don't be afraid. So notice at first we started with this mess, kind of, it's so confusing. And I took it sort of the first one down, and then these 2 up, down together. And then I did a few of those up, downs together to kind of figure them out a little bit. And then I helped try to figure out, okay, what's changing? The how many times the loop runs and where those upper loops start to drop from. So in figuring out that, I could figure out how many times they needed to happen. That's the 10, 1 to 10. I figured that out here. And then we kind of restarted to sort of figure out how these depend on each other. So that's tricky. I would encourage you to try that logic on paper for yourself. And this is it's kind of a great little trick one, but it's I think informative. I'll end it with the code in case you need to figure out where stuff is.